Hello everyone. Let's solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start with the question number 1. Question 1 says for the following set of simultaneous equation. Okay, we have given the equation. So now first of all, let's form an augmented matrix from this system. So what we are getting just simply here we have 1.5 minus 0.5. Here we have 1. Now here we have to write the right hand side. Here we got 2. Now in the second equation we have 4, 2, 3 and 9. Now on the last one 7, 1, 5 and here we have 10. So now to reduce this matrix we have to apply some row operation. So now first of all let's remove this fraction from this first row. So what we are going to do, just simply multiply this r1 with 2 and it will be new r1. So let's write it what we are getting after the multiplication. So now just simply here we get 3. Now here we get minus 1, here 2. Now on the right hand side we got 4. Now here second row will remain as it is 4, 2, 3 and 9. Third will also remain as it is 7, 1, 5, sorry 5 and 10. So now we have to apply further row operation. But now first of all look at this last row. We have 7 here first entry, and now add this two number 3 plus 4 will 7. Now in the same manner for this second entry here in the last row we have 1. Now again add these two. Now in the same order here we have 5 and again the sum of these two 5. So we can reduce this last row third row by row operation. So let's do it here. So I can write like this. I have to just subtract r1 and r2 from row 3. Sorry, here row 2, and it will be new row 3. So let's write here what we are getting after this operation. Sorry, here we have 1. Now 4. Now here we get 0, also 0. Here also 0. Now here we have 10 and we have to subtract 9. And we also have subtract minus 4 from this 10. So we are getting minus 3. So now you can see here rank of this matrix, this coefficient matrix which is here 3 cross 3, and the rank of this augmented matrix which is 3 cross 4. It is not exactly same. The rank of coefficient matrix is 2 and the rank of augmented will be 3. So we can say if a rank of coefficient matrix is not exactly same as the augmented rank of augmented matrix. Here we have the rank of augmented matrix, then we can say the given system of equation are inconsistent. So we can say these three equation have no any solution. So sorry, here not here we have y not x. Sorry for that mistake. So now we can say option B is the correct condition. The equation are inconsistent, so option B is the correct one. So okay, now let's solve question number 2. Question 2 says if A and B are non-zero square matrices, then if the multiplication of this A and B gives a zero matrix, which is also called a null matrix. Uh, if all the entries of any matrix are zero, then we can call it zero matrix or null matrix. If this is happen, then what the condition of A and B must be in such that the multiplication of these two will give the uh, null matrix. So now first of all let's write it. It is given that multiplication of these two will give zero matrix. So let's write here it must be a square matrix in the output also, because A and B are the square and it may be any order. So let here I am assume it is in 2 cross 2. So now what we have to do, just let take the determinant both the side of this equation. So what we get, simply the determinant of A times B equal to, we have to also take the determinant on the right hand side, and the determinant of any null matrix or zero matrix will also 0. So now we have we know that the determinant of this any two matrix that multiplied with together AB, it is just simply the multiplication of individual determinant. So we can write left hand side as like this: determinant of A times determinant of B, and we already have 0 on the right hand side. So we can say to get the 0 on the right hand side, at least either the determinant of A or the determinant of B will be 0. So we can say either, sorry so we can say either the determinant of A equal to 0, or determinant of B will be 0. Now this is the necessary condition to give the multiplication of this AB will be null. So now look at the option A. Option A says A is a singular matrix. So now in option A they are saying the A is the singular. Now it may be possible that A will be singular, but it may not be. But because if B is singular, then we also get the 0 out in the multiplication. So A is not always correct one, it may be, but we have to find the correct statement that we can imply from this condition. So now let's look at the option B. Option B says either A or B is singular. So we can say yes, it is the necessary condition to give the null matrix in the output after the multiplication. So we can say option B is the correct condition that we can say from this statement: AB, multiplication of AB will be null matrix. Now in the same way, we cannot not also conclude that B is a singular matrix. So C1 is also wrong and D is also wrong, because they are saying about the orthogonal and we have not used any concept of orthogonal here. So now we can say the statement B is the correct one. Now here the singular is just mean that the determinant of any matrix will be 0. Then we call it a singular matrix. So now that's it. We have find out the answer. It is option B. So now let's move on the question number 3. Question 3 says if A is any n cross n matrix, which is again the square matrix, and K is any scalar, then the determinant of this K times A matrix equal to the determinant of A times, here we have to find the value of this alpha here. So now first of all let's assume any general value for K. For example, let here K is an 3 cross 3 matrix. Let's for understanding the concept here, so let's assume in the general way. So now I have to find the value of this Ka matrix, sorry in the other word K times this matrix. So how to do it? Just simply let's Ka equal to, so we have to just multiply this all entries in the matrix with this scalar which is here K. So we can write Ka in the first entry, Kb and Kc. Now on the second row we get Kd, Ke and Kf. Now on the last row we can get Kg, Kh and Ki. So now we have to take the determinant of this Ka. So let's write it, determinant of Ka. So we also have to take the determinant on the right hand side. So we can write it Ka, Kb and Kc. Write the remaining entry as it is. So now we can take K out from this first row. So let's take it out. We can also take this K from this second row. So again let's take it out. We can also do with the same with this third row. So now again we get K. Now what we end up with here in the determinant, just simply the here A B C D E F G H and I. So now look at this portion. Here it is just simply nothing but the determinant of this matrix A. So we can write here what we are getting, just here we can say it is nothing but K to the third power, and here the determinant of A. So now compare this factor with the alpha in the that is given in the question. So we can say alpha, it is nothing but just K to the third power in the case of 3 cross 3, but here they are asking about the any matrix of n cross n order. So we can conclude from this or example, for any matrix, if it has an order of n cross n, then here we can say the determinant of k times a equal to just we have to raise this power of this vector k to the sorry, not alpha, so to the n, which is exactly same as the order of this matrix times the determinant of just first this uh, matrix as it is. So we have find out the value of alpha. Here it is just simply k to the n. Here value of alpha is just simply k to the power n. So now let's move to the question number 4. Okay, now let's solve question 4. Question 4 says the equation. Okay, we have given the equation in the form of determinant, and it is given that the determinant equal to 0 represent a parabola passing through the points. Okay, we have to find the points from this four option which are lies in the this parabola. And first of all, to do this, we have to find the equation of a parabola. So now, first of all, let's find the determinant of this 3 cross 3 matrix and equation is equal to 0. So let's do it here. So here, what we are getting just simply 2. I have to multiply these 2 x plus x square. I am just finding the determinant of this 3 cross 3 matrix. So let's write, and here in the last entry we are getting x square minus y, and we have to equate is equal to 0 because it is given in the question. So now let's do the simplification. So now we can see we can write here 3x square, this 2, and here this 1. So now here 2x minus x, so plus x. Now here we have minus y, again minus y, so minus 2 times y. Let's bring this 2 times y on the right hand side, so we can say it will be plus 2 times y. So now we need the value, we have to make the subject y as in subject. So let's write it here. So let's bring these 2 on the left hand side. So what we are getting just like this. Now we have find out the equation of parabola. It is given that this equation represents a parabola. So now what we have to do, just we have to go through option one by one. So, and we have to put the value of x, and we have to find what the value of for y we are getting for any value of x. So let's do it here. Let's start with the option A. Option A state if here this is represent the x coordinate. If option A state if x equal to 0, then let's first of all put x equal to 0 in this equation. What we are getting the value of y from this equation. So let's put here. So simply y will also 0 if x is equal to 0. So now this is the point which one is lies on this parabola. But in the option A, it is given that if x equal to 1, then y will be 1. But now here we are getting 0 or value of x equal to 0. So option A is not correct one because this first coordinate is not lies on this parabola. So now let's move on the option B. Option B, yes, it has this coordinate 0 comma 0, which is exactly same. So now let check for this 1 comma 2. Let if x equal to 1. So let's put here 1. So what we are getting, just put the value of x here equal to 1. So 3 plus 1, 4 by 2. Again, yes, we get y as in 2. So again 1 comma 2 is the point which is lies on this parabola. So again this point is also lies. Now let's check this third one. If it satisfies, then the option B is the correct one. Now if the value of x equal to 2, now here it is represented in the form of x comma y. So the first entry is an x coordinate. So here if x equal to 2, then what is the value of y we are getting from this equation. So let do put 2 here. So 4 times 3, 12 plus 2, 14 by 2. So we are getting 7. Then 2 comma 7 is the point which is lies on this parabola. But here it is given that 2 comma 1 point. So now again this point is not lies in this parabola. So option B is again wrong. Now let move on the option C. Option C has 0 comma 0. Yes, it is already we have find out. Now 1 comma 2. Yes, it is also lies in this parabola because we have find out the value of x and y here for this three condition. Now let check this third last one which is minus for the value of x equal to minus 1. So let x equal to minus 1. So let's put it here. So here we are getting 3 minus 1 2, and 2 by 2 is just simply the 1. So what we are getting just 1 minus 1 comma 1. So again yes, it is given in the question, option, that is minus 1 comma 1 is exactly same. Now these three coordinates are lies in the parabola because it is satisfying this condition. So we can say option C is the correct point of uh, correct set of point which are lies in this parabola. So option C is the correct one. So now let's solve question number 5. Question 5 says the number of term in the expansion of general determinant of order n. So okay, so they are asking about the if we expand any determinant of order n, then in the output how many terms we got. So first let's assume any matrix, square matrix, and let's expand it. So now let's assume first of all 2 cross 2 because it is easier. So now assume any general value, let's say in the form of a, b, c, and d. So now find the determinant. Just multiply these two diagonal and subtract the multiplication of these two, b times c. Now count the number of term that we are getting here. First term. Now here it will be second term. So you can say the number of term for this 2 cross 2 we are getting 2. So now here the value of n we have chosen as 2 because in the question it is given for general order n. So now we have select the value of n equal to 2. So put in the option. Put in the option. So now first of all let's put it in the option A. Here n will be 2 and 2 square gives 4. Option A state the in the expansion of 2 cross 2 determinant we get the 4 term. But here from this expansion we got only 2. So option A is the wrong one. Now let's move on the option B. Option B says the n plus 1 whole square. Here n is 2. So we got a 3 and 3 square will be 9. So again we are not getting 2. So option B is also wrong. Now let's move on the option C. Let's put n is equal to 2 in the option C. So what we are getting just simply again 2. So yes, option C is correctly describe the number of term for any 2 cross 2. So yes, C may be answer. Now let's check D also. Now here D gives n factorial. So here n equal to 2. So it's give 2 factorial which is again 1 cross 2. Yes, it is also again gives 2. So we are not clear about the either option C is correct or D is correct from this 2 cross 2. So now we have to move to the higher order to select the correct one from these two. So now let's move on the third 3 cross 3 matrix. Again assume any general matrix. So now here it is again we have assumed any 3 cross 3 general matrix. So now let's again expand it to find the determinant. So now simply just EI minus SF here minus B times. Now in the last term what we are getting just simply C times dh minus ge. So now let's multiply this bracket with this outer term. So now here what we are getting just simply. So now let's do it now in the same order. Here also multiply this term in the last term also. So now let's count the number of term that we are getting in the expansion of this 3 cross 3. Here first one, second, third, fourth, fifth, and 6. Okay, so any for any expansion of any 3 cross 3 we are getting in the output 6 term. So we can write here, let's write 6. So now again put n equal to 3 now because it is an 3 cross 3 matrix in the option C and D, and let's check which one is satisfying and giving the answer 6. So here option C gives again simply 3. So now C will be wrong. Now let's also check D for more clarity. So now here D gives 3 factorial, which is simply just multiplication of 1 to 3 numbers. So now again it is give 6. Now it is the exactly same as the this number of terms which are getting after the expansion of this 3 cross 3. So yes, we can say option D is the correct number of terms, which is just simply n factorial, and here n is the order of any general any determinant, sorry, order of any determinant. So D is the correct number of terms, sorry, n factorial is the correct number of terms that you are getting in the expansion of any matrix of order n. So now let's move to the question number 6. Okay, now let's in the question number 6, we have to find the inverse of this 2 cross 2 matrix. So now first of all, recall the formula of inverse. Simply just A inverse is just 1 upon determinant of this matrix A. Here I am calling this matrix as an A. Let's call it is matrix A. We have to multiply this factor with adjoint of this matrix A. So now we need the value of determinant. So first of all, let's find here. So minus 1, again multiplication of this to plus 1, and we have to subtract it from this minus 1. So simply we get determinant as minus 2. So let's put this minus 2 at place of this determinant. So we got minus 2. Now we have to find the adjoint of this matrix A, which is 2 cross 2. So now it is, remember, two step for determining, directly determine the adjoint of any 2 cross 2 matrix. And what are those two steps? First one, now just flip this diagonal element. So now this one will come at the place of this minus 1. So this element will come here. So now this element minus 1 goes to there. So now just write it here. So here we got minus 1 and here we got 1. So now to finding the remaining two entries, we have to just flip the sign of these two element. We have not to change the place, but just simply flip the sign. Here it is minus 1, so we have to write plus 1. Now here in the same order we have to write again plus 1, because in the matrix we have minus 1, so again minus, sorry, here we have to write plus 1. So now it is the direct shortcut method to determine the adjoint of any 2 cross 2. So now let's multiply this minus sign with this matrix, because in the option we have factorize plus 1 by 2. So what we are getting, just simply here 1 by 2 times this matrix. So here we have plus 1, minus 1, minus 1 and minus 1, and that's it. We have find out the inverse of this matrix A. So now from the option we can say that the B is the correct inverse of this A matrix. So option B is the correct one. Let's move on the question number 6. Sorry, not 6, 7. We are already at 6. Okay, now let's solve question number 7. Question number 7, it is asking the rank of this 3 cross 3 matrix. So just we have to do the row operation to reduce it. Sorry, here it is 3. So 3, 4, 5 and 4, 6, 8. So now first of all carefully observe this matrix. If we find any relation between this third row, so now between these three rows, so now first of all look at this last one. Here we have 4, number 4. So let's add these two number, so we get 4. Yes, so now here 6, again add these two, now 6, we have 8. Now it is just simply the addition of these two. So now from looking this matrix, one can say that this row 3 is nothing but just row 3 is linearly depend on R1 first row and second row. So from just simply looking this determinant matrix, one can say that it has two linearly independent row, which are this first one and second one. So we can say the rank of this matrix A is just simply the 2. It is the rank is nothing but just simply the number of linearly independent rows or column for any particular matrix. So now let's further, now let's reduce it. So this first and second row will remain as it is. Now here what I am applying the row operation, it, let's write also. Okay, let's subtract this R1 and R2 from R3. So R3 minus R1 minus R2 will be our new R3. So here we are getting a 0 0, because the addition of these two, and we are subtracting from this third one. So we are getting 0, 0 and 0. So now here one can easily say that rank of this matrix A will be 2, which is also the number of non-zero rows. Now we can further reduce this second row by multiplying this minus 3 in the first row and adding in the second. But here we cannot reduce this second row as all as 0, 0 because they are linearly independent. So we have not need to do it here because we are interested in finding the rank. So we got the rank of this matrix as in 2. So option A is the correct answer for this question. So now let's move on the next question. Okay, now here question 8 says for a singular matrix. Okay, so first of all recall whenever we call any matrix as a singular, if any matrix, let's call it A, as determinant will be equal to 0, then we can say here matrix A is singular if the determinant of any matrix is 0, then we can say the matrix is a singular. So now here it is given in the question that the matrix is singular, so that's mean determinant of matrix is 0. So now they are asking the condition of eigenvalue of this matrix, singular matrix. So let's first of all check option A. What they are saying in the option A? They are saying all eigenvalue would be at the origin. That's mean origin means all the value. Sorry, all eigenvalues have value as 0. So now use the other property of the eigenvalues, which is just simply the multiplication of these three. Now let's assume here it has three eigenvalue, lambda 1, lambda 2 and lambda 3. Now if we multiply these three number, then in the what we are getting, it is just simply the nothing but determinant of particular matrix. Here we have assumed it is here A matrix, and here in the question it is given that matrix is singular. So in the short we have given the value of determinant, which is 0. So now we have find out equation like lambda 1 times lambda 2 times lambda 3 equal to 0. Now if this is the condition, then at least either the lambda 1 equal to 0 or lambda 2 equal to 0 or lambda 3 equal to 0. Now from these three number, if any one number is 0, then we still get the multiplication as 0 in the output. So but option A says the all values are at the same time are will be 0. So now it is not the always the case. It may be, but it is not always the whole, because so we cannot say that option 1 is the always the case. So option A is the wrong. Now let's move on the option B. Option B says at least one eigenvalue would be at the origin. Yes, so they are in short saying this condition, either at least either the lambda 1 or lambda 2 or lambda 3 out of these three number, at least one. Maybe it is possible that two values or three, but they are given at least. So one value must be 0. So yes, option B is the correct condition about the any singular matrix in terms of eigenvalues. So now you can also say option C, no eigenvalue would be at the origin. So if this is the case, then matrix would not be a singular. So option C is not right. Option D is also not correct one. So only the option B is the correct condition for eigenvalue of any singular matrix. Okay, now let's solve question number 9. Question 9 says the value of following determinant. Okay, so they're asking about the determinant of this matrix. Now look at the matrix. Here it is an 5 cross 5 matrix. Now the if you want to find the determinant in the general way that we do for any order like 3 cross 3. So first of all we have to decompose this 5 cross 5 into the minors of 4 cross 4, and again we have to decompose 4 cross 4 into 3 cross 3. So it is very lengthy process and it take much time. But here look at the determinant, you can see some pattern. So now look at the all entries which are above this diagonal, they all are 0. Look at this these all entries. So now this kind of matrix has a particular name. What we are calling is just simply a triangular matrix. Now here the value all the value below the diagonal are non-zero. all values are below the diagonal and non-zero, so we call it lower triangular. If the case is reverse, in other words, if the all these zeros are here at this place and this number are at the place of zero, then we call it an upper triangular. And now recall, if any matrix has upper triangular or lower triangular, then it has one property regarding the determinant. So simply we have to use this property here. So now let's write what is the property. Now any matrix if any matrix is either it is lower or upper triangular, and now we have to find the determinant for any matrix if sorry here we have to write if is lower or upper triangular, then determinant of matrix is just multiplication of all, here it is all diagonal element. Now it is the property for any either the lower triangular or upper triangular matrix. So now just we have to use this property. Now here the order of matrix does not matter because here it is an triangular matrix. So just let's write it here. Now just multiply this all diagonal entries here. So now 1 times 2 times 3 times 4 times 1. So now let's do the multiplication. 6 multiply with 4, so we are getting 24. So now we have find out the determinant of this 5 cross 5 in the single step with the help of this property. We can also do for the any upper triangular like in the same order. So here the correct answer is the option A. Okay, now let's solve last question for this video. So question 10 says they are asking about the eigenvalue of this matrix. Here it is again a 2 cross 2 matrix. So we can find by finding the characteristic equation for this matrix. But here it is easier to use the property. Simply just if let's assume lambda 1 and lambda 2 are the corresponding eigenvalue, because here it is a 2 cross 2 matrix. If we add these two value, it gives simply the trace of any matrix. Here let's call it matrix again A, and now here just trace is just sum of this diagonal element. Here they are 5 and 9, so let's add these two, so we are getting 14. And now use another property, the multiplication of two eigenvalue. Here in this case it is just simply the determinant of this matrix. Here it is A. Now also let's find the determinant. So 9 multiply with 5, so 45 minus 6, so we are getting determinant as 39. So let's write it here. So now you can see here we got the multiplication as 39, but so 39 is a prime number, so we couldn't get any real number. Sorry, not real, any whole number. Let's give the multiplication 39. So option C is automatically wrong because it has a whole number 9 and 5. You can also multiply these two and you again get 45. So option C is not correct set of eigenvalue for this matrix. Now let check for the option A. Now let's sum these two. So what we are getting just simply 6 point something, but we are not getting sum as 14, and we required the sum of these two value must be 14. So option A is not correct set of eigenvalue for this matrix. Now let's also sum these two value from option B. So 5 plus 5.13 plus 9.42. So simply just what we are getting 14 point here 55. Now again you can see we are getting sum is 14.55. So C B is not also not correct one. Now the remaining one is D. Now also let's check it. Let's sum these two. 10.16 plus 3.84. Now let here 13 plus we have to add this decimal portion. It is again gives 1. So we get sum as in 14. So yes, it is satisfying this first condition. Let's also multiply these two terms. 10.16 multiply with 3.84. So now if we do the multiplication, we are getting 39.0.144. So now it is very close to 39. So we can say the approximate value of eigenvalue, approximate value for the eigenvalue of this matrix are given in the option D. So option D is the correct set of eigenvalues. So now that's it, and thanks again for watching this video.